Hi everybody, good morning. So I checked your homework and many of you get 25 points. Good. But some of you still didn't get 25 points. You know you can redo the homework again and again until you get the perfect scores, right? So keep doing the homework until you get 25 points. And do you have any questions on the homework? Is the homework sample solution helpful? Yeah. Are you able to look at the sample homework solution and like look at how to solve the problems and then work on your problems? Okay. Yeah. So all of our homework is like that. Okay. So this week you don't have any homework to do this week, but I suggest you to keep working on it. You know that one homework set is long, right? So yeah. And the second homework is due next Friday. And quiz 1 will be about homework 1 and homework 2 stuff. Okay, everybody? Yes.
Quiz 1 is in class.
Quiz is in Blackboard. So you go to Blackboard and you click quizzes. There are 7 quizzes. So on that day, so first quiz is September 15th. On that day, after the midnight, the quiz will be available. So right now, this quiz is hidden. It will be available after the midnight of that day. And you have a whole day to start the quiz. Once you start it, so for example, when you click that and you begin the quiz, then you have to submit in 30 minutes. Okay? So do you see this file? This is the quiz questions. It usually has 1 or 2 questions. It depends on how hard it is. And usually it will take about 15 minutes to complete. I give you 30 minutes because you might need time to like take pictures and upload and submit. So I give you more time. So after you finish, do you see this browse local files? Okay, so you click this button and then you can attach the file there. Okay, so for the quiz, you can submit image or PDF, but don't submit HEIC. And on some phone, take pictures and then the picture is saved as HEIC. Do you know that? So make sure your phone is not saving the picture as HEIC. I think maybe Apple do that.
We're supposed to take a picture
Oh yeah, your homework you don't need to take a picture.
Okay.
Your homework just do it in Blackboard. But I strongly recommend you to solve your homework on a notebook. So when you review for the exam, you can look at your homework. And if you have a mistake on your homework, use red pen to cross out and then redo the problem again until you get the perfect scores on your homework. In that way, you can have things to study for the exam. Think about it before the exam, what did you study? You study the in-class worksheet, right? And then you look at your homework and see what mistake you made and try to avoid making the same errors again. And then you review your quiz. That's how you study for the exam. Now, I also have practice exam posted on the website. So you can work on those problems. The practice exam is like a study guide. I will test you like similar type of problems, but I don't promise they have the same difficulties. So maybe your exam problem is harder, or maybe some problem is easier, but it's that kind of problems. Is that okay, everybody? Mm-hmm. Yeah, so you attach the files and then hit submit. Okay? Questions?
So on the day of quiz, do we have classes?
Of course. Of course. We only meet like 3 times a day, and every day, just 15 minutes. We have a lot to cover. That's why I moved the quiz to be online. But the exam is in class. Okay, so quiz and homework online, but exam is in class. Okay, and the exam, I want to give you more time. So like we meet here at 10 to 10:50. So I come here at 9:45. So if you finish your other class, okay, your previous class, if you want them in here, then you can start early. And I teach calculus too in this classroom after our class. So if you haven't finished, feel free to stay longer. Okay, so stay longer, 15 to 20 minutes. Don't stay my one class period longer. That's too much longer. Yes. Okay. Right. So that is our plan. Oh, by the way, so I strongly recommend you use your phone to open use your laptop to open the quiz, because I do have students use the phone, the Blackboard app to open the quiz, and then when they take the picture, they get locked out. Okay, so use your laptop and then use your phone to take pictures, and then email yourself the picture. Then you can use your laptop to download the image and then upload here. Okay, and if you I set the setting to be unlimited attempts. So if you accidentally get logged out, open the second attempt right away and then upload the file and submit. Okay, but if you use more than one attempt, you have to email me and tell me why. Maybe your internet is not stable, or you got locked out. So I totally understand it, but just let me know why. Okay? Yes. So you can have more than one attempt. If you get locked out, don't just give up and then you get 0 on the exam. Okay? Open a second attempt and attach it. Okay? All right. Good. So today let's continue. So last time we talked about how to evaluate limits. Okay, let's review the steps. Step 1, we plug in the number, right? Plug in number. But if we see something weird, like 0 over 0, then we know there is a bad guy, right? And then depending on the problems. So if you see polynomial, you need to factor, right, everybody? And if you see square roots, it's actually like difference of square roots, then you multiply by its conjugate. Conjugate means don't change the sign. Inside the square root, it's outside the square root, you change the sign. Okay, don't change anything inside the square root. It must be the same thing here. And we're using a minus b times a plus b is a squared minus b squared. The a square and the square root cancel. That's why we can get rid of the square root. Okay, everybody? So in this case, you can simplify it, factor, and then when you see the bad guy, it has to be the same. X minus 4, x minus 4. It has to be the same. If you see x minus 4 and here 4 minus x, you need to flip one of them. And if you flip them, you get a sign in front of it. Right, everybody? Mm-hmm. And after we cancel the bad guy, we can then plug in the number again, and you will get a good number, not something weird like 0 over 0. Okay, everybody? Yes. And also, one kind is if you see fraction, combine into a single fraction and simplify it. Okay, combine in a single fraction, you need to look at the common denominator, right? And simplify it, you don't want to see fraction in a fraction. So use this a over b over c over d is a over b times the reciprocal, which is d over c. Do you all remember this? Okay, so like 3 types of examples we have seen. Polynomials, different square root, and fractions. Okay, so now you are able to do all the 3 kinds of it. So that's about limits. Okay, next, if we have a piecewise function, how to evaluate the following? Do you remember at the beginning of 3.1, I give you the graph, and then you look at the graph, look at the endpoint, whether it's open circle or solid circle, you can figure out the function value and the limits. Right, everybody? So here, I don't give you the graph, but I give you the formula of a piecewise function. Attendance. Where is it? Okay, here. All right. Okay. Thank you. Okay, so here, everybody do you still remember the piecewise function? Okay, you look at the x values, and then you figure out which piece it lies in. So here, x less than -1. All right. So let's draw pictures. Okay. All right. So -1 is here. X less than -1, we're using the first formula. Right, everybody? And then from -1, including the -1 to the 2, we're using the second formula. Right? And then greater or equal to 2. See? Greater or equal to 2. So it's a solid point. And then here, we're using the third formula. Okay? So that's the piecewise function. The domain is all real numbers. See, these 3 intervals, it covers the entire real number line. Right, everybody? Okay, now let's look at the following. K of -2. X is -2. Where is -2? It will be less than -1, right? So we use the formula 1. Use the formula 1. Okay, so let's write it down. K of -2, we use formula 1. So whenever you see x, replace x by -2 parentheses. Right, everybody? We have x here. Erase the x, replace x by -2. But don't forget the parentheses. Parentheses is our baby. Who's your baby? Parentheses. Yes. Okay. What is -2 squared?
4.
4. 4 times 2. 8. 8 plus 1. 9. Right, everybody? Mm-hmm. Good. Okay, how about you guys take turns to answer my questions? Hi, Blaine. Good morning. Okay, so part B. K of 0. Where is 0? Yeah, the second function. Okay, so we plug in the second function. What do you write?
You write so 0 plus 4.
Yes, which is?
74.
Yeah. Right, everybody? Good. Okay, C. K of 2. Will. Which piece? Where is 2?
2 is greater than or equal to?
Yes. So which piece do we use?
The third one.
Yes, the third one. When you plug in 2, what do you get?
You get -2 minus 5, and then that's -7.
Yes, very good. Right, everybody? Okay, part D. Limit x goes to -1 plus. So plus is like from the left side or from the right side? Dylan. From the right. Okay. -1 here, right? We're approaching it from the right. Which formula do we use? The first one or second one? Second one. Right, everybody? So we're right here. So right here, use the second one. Then what do you write? Okay, how about let's do one more step, okay? We write down the second one. The second formula is x plus 4. Right, everybody? Okay, now what do you do? So you get, which is, yeah, very good. Yes, everybody? Okay, page. -1. What's minus sign mean? From the left. Oh, which formula do we use? The first one. Okay. So we write down limit. Okay. From the left. We use formula 1. Okay. Write down formula 1. 2x squared plus 1. Then what do we do? Yes. So what do we write? Yes. And don't forget our baby parentheses, right? And then what? Plus 1. What do we get? 3. Oh. Do you see that this is the right side limit? This is the left side limit. Do you see they're the same? So what do you say? The limit at x goes to -1. 3. Yeah, everybody, if the two-sided limit agree, then the limit exists and equals to that number. Okay. So this is 3 because these two are the same. So therefore, we get the limit is 3. Okay, good. So keep going. G, limit x goes to 2 plus. All right. Next, Mackenzie. 2 plus. Which formula do we use? 3. Yes, we're going from the right. Yes, everybody? Okay, we use the third formula. So limit x goes to 2 from the right. The third formula is negative x minus 5. Remember, every step, if you still have x in your steps, you have to carry the limits. Is that clear, everybody? Otherwise, 1 point will be off in the exam. Okay, if you miss the limits, that'll be 1 point. Okay. Alright, Mackenzie, so what do you do? Yes. And then what do you get? Yeah, very good. -7. Alright. Continue. H. X goes to 2 from the left. Okay, of x. Okay, Gabby, which formula do we use? Yeah, the second formula. So, second formula is x plus 4. What do you do? Yeah, 2 plus 4 is 6. Right? Good. Dante. So, what do you say the limits x goes to 2? Remember, undefined, we use it to describe function. Yes, does not exist. We use it to describe limits. Very good. So far, so good, everybody? Yeah, so this is how we, yes, solve this example. We don't have the graph, but we have the piecewise function. We have the formula. So my recommendation is like you draw this picture and then it help you to visualize which piece, which formula you should use. Okay? Mm-hmm. And so here our functions very simple, just polynomials. But in the exam, you will expect to see logarithm function or exponential function, right? Any trig functions. Okay, but it works very similar. You just plug in the numbers. Okay, but remember for trig functions, when you plug in number, you use which mode? Degree or radian? Radian mode. Okay, everybody, use radian. for the trade function. All right, very good. Okay, so next page. Infinite limits and limits at infinity. So big idea. Infinite limit arises in the limits in two ways. The first way, vertical asymptotes, when the limits of a function tends towards infinity. For example, like let's say a is here, we have a vertical asymptote there, so our function looks like this. Okay? In this case, x is approaching to a finite number, but our y goes to infinity. Okay, everybody? So yeah, the vertical asymptote is like the y goes to plus or minus infinity. And then the other case is end behavior of a function when the x values of the limits goes to infinity. So in this case, we have the x goes to infinity, or actually it could be positive or minus infinity. So the picture is like this. So we have something there, maybe, and at the end it looks like this. So in this case, it's like, what is the behavior when x goes to infinity or minus infinity? Okay, so two cases. Is the y goes to infinity or the x goes to infinity? We can think of it this way. And we'll do both. So let's first do what happens when the y goes to infinity. Okay, so big excuse. You should be able to evaluate limits corresponding to vertical asymptotes, horizontal asymptotes, or slant asymptotes by graphing the function and using algebra skills. Okay, so suppose f is defined for all x near a. If f of x grows arbitrarily large as we like by taking x sufficiently close to a, but not equal to a, then we write limit x goes to a. So the picture is like this. We have a here. When x goes to a, our f of x goes to infinity. Something like this. So this is the picture. Okay, so it goes to a. My y value goes to infinity. So we say the limit x goes to a, f of x is infinity. Okay, everybody? Alright, and similarly, we have minus infinity. Okay, so let's say a is here, maybe this picture like this, and this picture like that. So when x goes to a, the y goes to minus infinity. So minus infinity is very down. Positive infinity is the top. Okay? In both cases, we say the limit does not exist. Actually, we have seen this before. Remember last week? I said does not exist. You can still have three types. Is infinity, then like this picture. Minus infinity, it's like this picture. And the other one is like, oh, your left endpoint and two endpoint, they don't match, so the limit does not exist. Or it could be something like oscillating very fast between two numbers, so the limit does not exist. So in this case, you have to just say does not exist. You cannot use infinity or minus infinity to describe it. Yes?
What if it's like they're both going opposite directions?
We still say does not exist. Okay. Because it's like infinity and minus infinity, they're different. And actually, it's quite different. It's like heaven and hell. So different. So the two side limit do not agree, and the limit does not exist. Yeah, very good questions. Okay. Right, so we have now like these pictures. And similar definition can be given for one-sided limits. Okay, everybody, look at this picture. See the graph? It's left, right? And we go to infinity, and it's top, right? Left, top. So left means x goes to a from the left, negative, okay? And the y goes to infinity. So this is infinity. Here, left or right? Right. Top or bottom? Top, right? Look at this point. So right away from the right, positive. And then the y goes to infinity. Yes? Here, left or right? Left, top, bottom. Bottom. So left, x goes to a from the negative side. And bottom, y goes to minus infinity. Okay, everybody? So 4 directions. And then this one, right bottom. So x goes to a from the positive side, and then y goes to minus infinity. So we have these 4 cases. Okay, left or right, top or bottom. Okay, so all right. The line x equals to a is called a vertical asymptote of the curve if at least one of the following statements is true. So you either have the two-sided limit goes to infinity or minus infinity, or one-sided limit goes to infinity. Okay? All right? So anything this happens, then we get a vertical asymptote at x equals to a. All right, so let's continue. Find the limits of the following. Okay. All right. So let's see. Okay. Everybody keep in mind that 1 over 0 plus is plus infinity. Everybody okay with that? Because 1 over a very small number is going to be a big number. Yes? Do you still remember from last week? 1 over a small number like 0.001 is 1,000. So 1 over a very, very small number is going to be a so big number. So 1 over 0 plus is plus infinity. 1 over 0 minus is minus infinity. Are you okay with this notation? So 1 over 0 is undefined. But 1 over 0 plus is some number close to 0. Get it close to 0, but never equals to 0. Okay? Similarly here, this is some number close to 0, but negative is never equal to 0. Okay. And also you have 1 over infinity is 0. 1 over minus infinity is also 0. Yeah? We know 1 over 1,000 is 0.001, right? 1 over a big number is going to be a very small number. Okay, so keep these in mind. Okay, now let's do it. Look at the first one. So limit x goes to minus 7. Do you realize when x goes to minus 7 plus, what does that mean? Well, this means x is greater than minus 7. Yes, everybody? You're approaching it from the right, so x is greater than it. Yeah? And so, therefore, the x plus 7 will go to 0, but it will be from the left or right. Think about it, x greater than minus 7, so you add 7 on both sides. Do you see you get x plus 7 greater than 0? So x plus 7 will go to 0 from the right. Is that okay, everybody? Sure. So x goes to minus 7 from the right. From the right means x is bigger than it. Right? So your minus 7 is here. X is going to negative 7 from the right. So x is bigger than that, right? And because your expression, you have x minus 7 in the denominator. So you want to figure out what is x plus 7. So therefore, x goes to minus 7, but x is bigger than it. When you add 7 on both sides, you get x plus 7 is bigger than 0, right? So x plus 7 will go to 0, and then you're greater than 0. So you're approaching it from the right.
So don't you know when you like just plug in the
You plug in a -7, you get 0. But then how do you figure out it's 0 plus or 0 minus? So I'm showing you it's actually 0 plus. Okay, so I'm showing you for this time and right now like the details. But if you understand it, then you don't need to show such detail. Okay, everybody? So therefore, you can say this guy is equals to limit x goes to -7 plus. Now plug in. Look at your numerator. Your numerator, you plug in -7. So 2 times -7 plus 1. Look at your denominator. X plus 7 is 0 plus. Is that okay, everybody? And what's the numerator? What's 2 times -7? Joseph? -14. Plus 1 is -13 over 0 plus. Right, everybody? A constant over 0 plus or 0 minus, you get infinity or minus infinity. But here, how many negative signs do you see? One negative sign. So it will make it to be negative infinity. Yes. So the answer is negative infinity. Is that okay, everybody? Good. Let's keep going. All right. So these things, I just want to explain you more. Okay? So you know that. Okay, let's look at this. If x goes to -7 from the left, what do you say x plus 7 goes to? It goes to 0, but 0 plus or 0 minus? Yeah, 0 minus. And your numerator, you also plug in -7. Right? And what's your numerator? Again? -13 over 0 minus. What's your answer? Positive infinity. Because we see two negative signs. Two negative signs make it positive. Right, everybody? Actually, if you have an odd number of negative signs multiplied together, you get the answer is negative. If you have an even number of negative signs multiplied together, your answer is positive. Okay? Alright, so, what's this? Your right side limit is minus infinity, your left side limit is infinity. What do you say the limits? Yeah, the limit does not exist. Is that okay, everybody? And in this case, we can say the vertical asymptote is x equals -7. Yes, because to have vertical asymptote, you just need to have one side limit to get infinity or minus infinity. Then you have a vertical asymptote. Okay, everybody? Yes, so this is rational function. We have a vertical asymptote. Okay, and so here you realize that this corresponds to the denominator is 0. Okay, so it's very easy to think about, if the denominator of a function goes to 0, then we have a vertical asymptote. Well, you gotta be careful with that. It's not always the case. You know what I'm saying, everybody? Yeah, look at this example. I have my denominator x minus 2, okay? But the fact is, the numerator, when you plug in, you also get zeros. So 0 over 0 is weird. We don't know what it is. So you need to simplify the function. Actually, you can factor the numerator. Do you see the numerator? We have a back out x minus 2. So after you cancel the back plus 1. So you can plug in the 2 again, you get 3. Do you see here, even though my denominator is 0, but do we have a vertical asymptote at 0? Wait, at x equals 2? No, we don't. This is actually a hole here, right? The left side limit and the right side limit actually match. The limit exists. Okay? So later on when we talk about continuity, we will say this is a removable continuity because you can remove this holes by filling in the points. You can redefine the function and you define f of 2 to be 3. Then this will be a continuous function. So we'll talk about continuity later. Okay. But this example tells us when you find vertical asymptote, you cannot just look at the denominator and set it equal to 0. You really need to compute the limit. Okay, everybody? You really need to make sure you have positive infinity or negative infinity. Okay? If you get a number, then we don't have a vertical asymptote there. Okay. All right, very good. So now let's look at example 2. Find all vertical asymptote of the following function. Okay. So when we see a new type of problem, I would like to write down the steps. Okay, so when you see a new problem, then you can follow the step and work on that problem. So the first step, I would say, is factor. Okay, this example is already factor, which is nice. But like this example, if it's not factor, then you factor. Okay, everybody, and cancel the common factor, simplify it. So that's the first step, factor. And then the second step, find the domain. And if you have rational function, you set the denominator not equal to 0. Alright? And you find many points. Step 3, compute the, so check when x goes to those numbers from the right. What happened? So what is the limit x goes to a from the right f of x? If you get infinity or minus infinity, then we have a vertical asymptote. Can I just put VA for vertical asymptote? And the vertical asymptote is x equals to a. All right? And if you get a number, okay, if you get a number, well then you have to check the other side as well. Because you might have the picture like on one side, the limit equals to a number. But on the other side, it might go to infinity. In this case, we still have a vertical asymptote. Okay, everybody? So to show there's no vertical asymptote at a point, you need to check both sides. Is that clear, everybody? So if you get a number, then you need to check for both sides. So you need to check what limit x goes to a f of x equals a number. Then in this case, you get for sure there's no vertical asymptote. Is that okay, everybody? To show there's a vertical asymptote, you just need to check one side. You go to infinity or minus infinity. To show there's no vertical asymptote, you need to check both sides to make sure both ends they don't go to infinity. Is that clear, everybody? So here are the steps. Let's work on this problem. Step 1, factor. Can we factor further? No, it's already factored, right? Yes. So good. So the next step, we find the domain. Domain is when the denominator not equal to 0. Okay. All right. So yeah, keep in mind these steps. Because I do have sometimes students trying to multiply out. No, don't multiply out. That's not our goal. Okay? Our goal is we want to have the fraction form. So don't multiply out. Knowing what you're doing. Okay, so set a denominator not equal to 0. Well, then you set each factor not equal to 0. Right? Everybody? So we have 2x plus 7 not equal to 0 and x minus 8 not equal to 0. Solve for x. What's x? Layla, not equal to? Yes. And here x not equal to 8. Right. So those are the numbers we check. Right, everybody? So we have two numbers. So we need to check. And usually you just need to check for one side of limits. Okay? So I suggest you to check the right-sided. Because the right-sided, positive is good. Because positive square is still positive. And negative, you have to be careful. Negative square is, it becomes positive, so it will change. Okay, so to make things easy, let's check the right side of limits. Okay. So therefore, limit x goes to -7/2 from the right. Okay, what is that? Let's call this step 2. Step 1 is already factor. Step 3. Okay, and now this is, we try to plug in. We plug in x is -7/2. So 5 times x. X is -7/2. And then minus 2. X is -7/2. And then plus 3. Okay. Next one. Do you see this factor? Yes. Do you see this factor? And because when x goes to -7/2, this factor actually goes to 0. Okay? 0 plus or 0 minus? 0 plus. Yes. 0 plus. Okay, don't just put 0 because then you get undefined. Don't put 0. It's 0 plus. And then the other factor, you can just plug in the x is -7/2. Okay. So do you see we have constant over 0 plus? So now what we want to do is figure out how many negative signs. Okay? You don't need to plug in your calculator and tell me what exactly the number is. You just need to figure out, is this number positive or negative? 5 times the negative number is negative, right? Negative number minus a number is negative. So this is negative. How about here? What's 3? 3 is what over 2? 6/2. When you subtract 7/2, this is plus or minus? Positive or negative? Negative. Right? Everybody? Negative. Alright, how about -7/2 minus 8? Positive or negative? Negative. Okay. How many negatives are there? So 1, 2, 3. 3 negatives, so your answer will be negative.
Can you put a bottom of the plus?
Ooh?
That's too big. Oh, no.
Yeah, negative and minus. Yes. So 3 negative, our answer would be minus infinity. Okay, everybody? See, we have a factor, so you just need to figure out which factor is positive or negative. Do you need to plug in your calculator? No. You don't need to use your calculator. Okay? We just need to figure out whether each factor is positive or negative. Alright, so if we get minus infinity, good. Yes. Oh, when we do this, and next step we're gonna check this number. Oh. Yeah. We have two numbers. We need to check both. Yes. Here we get minus infinity, then we know this is the vertical asymptotes. And then we also check this point too. Yeah, very good. Okay, so let's see. Limit x goes to a. Left or right? Left? Do we want to check the left? Right. Yes. Always check the right. Because if you check the left, so it's 0 plus, sorry, it becomes 0 minus, the 0 minus square will become 0 plus. So it might change sign. So I'm afraid like might make mistake. So to reduce the chance of making mistakes, let's just stick with the right side limits. Yes. Okay. All right. So we plug in 8. 5 times 8 minus 2. Right, everybody? We plug in x is 8. And then 8 plus 3 cube. Oh! I have a mistake. Do you see this is cube? I forgot the cube. But thankfully, yeah, negative cube is still negative. So it won't change our answer. But if this is square, oh, right? Okay, so I have the cube. And next one, the 2x is 8 plus 7 times. What do you put instead of x minus 8? Yeah, 0 plus, very good. Okay, let's figure it out. 5 times 8 minus 2, positive or negative? Positive. 8 plus 3, positive. 2 times 8 plus 7, positive. Oh, what's your answer? Positive infinity. Right, everybody? Good. For both numbers, we get infinity. So we say vertical asymptotes are x equals to negative 7 over 2 and x equals 8. Another mistake that a student might make. So don't just answer the number. Okay? Vertical asymptote, they're vertical lines. Vertical lines give me an equation. X equals a number. Okay? Give me an equation. Don't just give me negative 7 over 2 and 8. A number does not mean anything in the xy plane, on the xy plane. Okay, everybody? All right, very good. So this is example 2. How about you try a little bit of example 3? You might not finish, but at least, what's your first step? Factor, yes. Factor. Try to factor it. on Friday. Alright, so remember your homework one, if you didn't get the perfect 25 points, please do the homework again and again until you get 25 points. If you have any questions, please feel free to come to ask me in office hours. Right. And you can see my office hours on the portal if you forget. Have a nice day!